In 90 days, you would reverse your immune health by 47%.
Reduce the rate of aging of the immune cells by 47%.
That's amazing.
80% of autoimmune diseases seen in women. That's a fact. Does that mean that females have a weak immune system?
We resume our discussion with Dr. Jeff Bland,
advancing into the science of immunorejuvenation
and the body's incredible capacity for healing.
Why are we so sick?
It's because our genes stayed the same, but the environment in which they're exposed has changed dramatically.
Is it true that women who haven't had babies or been pregnant don't have as much immune disease?
Yes, there is a correlation between childbearing and autoimmune disease. If you were to only measure one thing that would determine the year of your death, it'd be...
Welcome back, Jeff. It's good to have you again.
Dr. Hyman, I can't tell you how excited I am to really keep exploring together what we could create. It's always fascinating to me to see what our mind meld can produce.
It's kind of scary sometimes. But, you know, Jeff, so many people out there are suffering and suffering needlessly. You know, like there's certain things we can't control. Given where we are in the evolution of medicine and science, not what's in practice clinically or in academic centers or in hospitals or your doctor's office, but where the science actually is around medicine, we now do understand how to relieve so much needless suffering. And right now we're having so much of that. I'd love you to sort of unpack to start with, what is the reason we're having this epidemic of chronic disease? Why are we so sick?
Yeah.
Yeah.
It's because our genes stayed the same, but the environment in which they're exposed has changed dramatically. 50,000 new chemicals of unknown toxicology introduced in the environment. Increased stress patterns, time urgency with social media, environmental changes in our climate that cause all sorts of different changes with bugs and pathogens, and the biosphere, which has changed, the loss of biosphere diversity, the simplification of our diet. There are 30,000 edible foods, of which we constitute 90% of our calories from less than 8 foods.
That's right.
And so when we started asking,
3 make up like 60% or something, yeah.
So when we started asking, what are the things that our genes never knew they were going to be exposed to over the course of a very short period of human history, we're talking like less than 100 years, much less, our genes can't mutate fast enough to keep up with that. So what happens is...
That heart attack in the 1900 was like a rare disease.
Right.
Diabetes was super rare.
In fact, in 1900, I remember reading some of the original reports saying if there was a heart disease patient in clinic, they used to run over and try to see them because they may not see another one in their practice.
That's right.
And so these things that we take for granted today, and then we layer on top of that, of course, things like autism and like atopy and allergy and asthma
and autoimmune disease.
Eczema and autoimmune disease. Where are these all coming from? Our genes have stayed the same.
And these weren't that common before.
No.
And in indigenous cultures around the world, these are primarily absent.
This is not like a big discovery process. All you have to do is ask the right question. The answers are very obvious. Our genes have stayed the same. We didn't suddenly mutate into autism genes. We didn't suddenly become autoimmune because our genes changed. Our environment changed, which sends signals to our genes to respond in such a way that it produces what we then call clinically a disease. We give it a name. Now, what it is a maladaptation, and let's call it an adaptation to that changed environment. Now, given that, then what the heck do we do? We're not going to change our genes, at least at this time. Maybe there will be genetic engineering later where we will. But today, we've got those genes. What are we going to do? What we want to do is to modulate how the genes respond to that environment so they're not overreacting. Let me give you an example. Autoimmune disease. I have a whole different take on autoimmune disease than probably most every rheumatologist in the world. So here's my take. 80% of autoimmune diseases seen in women. That's a fact. There are 88 different diagnoses of autoimmune diseases that have different names, different reimbursement codes.
Like MS or lupus or Hashimoto's.
Type 1 diabetes.
Type 1 diabetes is a ton of them, right?
If we then take those 80-some diagnoses that all associate themselves with autoimmune disease, then we ask the question, and 80% of those are found in females, then we ask the question, does that mean that females have a weak immune system? That they're born with an imperfect immune system? Or, here's my model, they're not born with an imperfect they're born with a perfect immune system to adapt to that which is the biggest stress on their immune system that a woman will ever have. It's called childbearing. Now think of what happens if you have a child in the womb that doesn't have your genes. Well, it has part of your genes.
Yeah.
It may be even a different gender. And now your body has to accommodate that. If you put that in a male's body, you're going to have problems.
Yeah.
That person's going to have probably an acute immune catastrophe. But in a woman, that immune system has to accommodate that and nurture it and successfully
Well, that's an
deliver
interesting
it.
question. Just to jump on a sidetrack here for a minute, is it true that women who haven't had babies or been pregnant don't have as much immune disease?
Yes, there is a correlation between childbearing and autoimmune disease, right? That's a whole other interesting topic. Rather than tell that woman you have an imperfect immune system, we might say you have a very adept immune system for finding out that something in the environment is not right. Maybe you're the yellow canary, because eventually maybe that signal that you're picking up will be seen in everybody if it becomes severe enough or high enough level of exposure. Now, what used to be just in a few now becomes in many. It's just that you are genetically more responsive. So you have a super good immune system, it turns out.
Yeah.
So rather than calling you damaged, merchandised, or wrong, what we need to do is take the uniqueness of your immune system and find out how to detune it in response to that particular thing that's alarming it, because your alarm mechanism is going off. And our job on the practitioner side is to help interrogate what we're going to do to produce an environment that your immune system will find favorable.
This whole puzzle of chronic disease, why we're seeing this epidemic, some people say, oh, well, we didn't have it before because we didn't live that long, and everybody died at 40.
Baloney.
And that's not really not true. A lot of people live to be very old.
Baloney.
In many, many cultures. I mean, yeah, if you were born...
What about children with NASH? How about teenagers
liver.
that have fatty liver disease? When I was in school in the 60s, there was no such thing as fatty liver disease in children.
Not when I was in school in the 80s. Yeah.
This is ridiculous fallacy.
But the idea that, that we these chronic diseases are only occurring because we're getting older and they're sort of normal part of human development and aging, that they're kind of inevitable, is sort of something I've heard people say, but I think there's a real flaw in that, because when you look at the historical records, like, for example, the Native Americans in the plains, they had this highest number of centenarians of any population at the turn of the last century, and they were living on bison. And yes, you had a lot of maybe death in childbirth, infant mortality, that would affect life expectancy. But we have extended life expectancy because of sanitation and hygiene and a lot of reasons, better medical care in some cases. But these chronic illnesses of aging, which we've come to expect as normal, heart disease, cancer, diabetes, dementia, and even things that we don't think of as disease of aging, like mental health issues, depression, anxiety, bipolar, schizophrenia, ADD, autism, Parkinson's. I mean, these are things that we now are understanding are connected to inflammation. I remember back in 1997 when this paper came out in the New England Journal by Paul Ritker, which essentially was a Harvard professor that showed that people with high levels of inflammation had a high risk of heart attacks. And there was follow-on studies where they showed that if your cholesterol was high but your inflammation was low, you had a low risk. But if your inflammation was high and your cholesterol was low, you had a high risk. So basically it was the inflammation that was the problem, not the cholesterol. And pathologists would see in the plaques in arteries back in the 50s, 60s, 70s, they would see macrophages and they'd see, T cells which are part of the immune system, in the plaque. And they just didn't know what to make of it. And they thought it was just a plumbing problem and fat build up in your arteries from eating fat. And that was an overly simplistic model. And now what's happened since that seminal paper from Paul Ritker at Harvard linking inflammation and heart disease, inflammation is now connected to all the chronic diseases of aging and aging itself. And so when we look around us, it seems like the final common link between all these chronic illnesses that we're suffering from in today's society are related to inflammation and that some dysregulation of the immune system.
You use the word macrophage. So the macrophage is an immune cell that's a member of the first line of defense, the innate immune system. So the macrophage has this ability to go in and out of cells. It travels in your bloodstream, and then it can come up to a plate on your blood vessel wall, and by a message, it can say, hey, I should go inside and interrogate what's going on inside the blood vessel wall. And there's several layers of the blood vessel wall. So it goes through the first layer, which is the endothelial level, and it gets into the intimal level. And then eventually it sees if there's something funny going on in there. And if it sees something funny going on, it does what it's supposed to do, is to get rid of funny business and attack it as a foreigner. So it does a macrophage engulfment, and it goes through its process, which is killing by chemical warfare. through the release of oxidants. So what could be inside that vessel wall that would precipitate that? It could be many different things, one of which could be oxidized LDL. There could be subparticles of cholesterol that are been modified.
Rancid fat, essentially.
That's exactly
which
right.
Which is kind of foreign. It's not a normal lipid.
Precisely. And so now
or
it's
microplastics, which are now found in artery walls.
Yeah, so it's doing what it's supposed to do. It's seek and destroy foreigners. The problem is we need to not just stop the macrophage from working. Let's just block its function by giving an anti-macrophage drug. Let's find why it would find a foreigner there and treat that so it doesn't have to be in an alarm state.
You just unpacked why we have so much chronic disease. It's our crappy diet, which is full of processed foods, limited amounts of variety of foods, lack of protective nutrients, lack of nutrients and vitamins, minerals, an overload of environmental toxins and chemicals, from petrochemical toxins, from heavy metal toxins, from all the things we're exposed to. The stress we have, the sleep disruption, this lack of sort of regulation of our circadian rhythm, the lack of connection socially, and so many things that are impacting us. The overuse of certain drugs like antibiotics, the increase in C-section rates, the increase in bottle feeding and lack of breastfeeding. I mean, all these are compounding over generations to have the worst epidemic of chronic disease in human history. And we are the epicenter in the United States. All these issues and all the things we talked about, at the end of the day, come down to a problem with the immune system. And this is really what the sort of amazing discovery is that we're going to unpack today, which is, how does your immune system connect to these diseases? We now sort of understand why it's dysregulated, which means we can do something about it. And we're going to get very specific about how modifying certain things like diet or certain plant chemicals or phytochemicals, for example, like from a Himalayan Tartary buckwheat, an ancient food that was used for thousands of years, actually has chemicals in it, phytochemicals that regulate the immune system. And we now know this on a granular level. So we're seeing this sort of on one hand, this rising understanding of chronic disease being an inflammatory state, aging itself being an inflammatory state if we don't properly understand how to regulate that. And at the same time, we're seeing this rise in our ability to have really granular understanding diagnostically of what's happening at the gene level, at the epigene level, at the immune cell level, and ways that we never did before, that are kind of uncovering relationships and connections and things that help us to understand how to modify our lifestyle and our diet and our habits so that we can properly regulate our immune system so it does the right thing, which is to fight foreign invaders when we need it to, but not to do the wrong thing, which is to be overactive in a state of chronic disease or an autoimmune disease or an allergy, right? We don't want that. So how do we sort of start to think about the immune system? Sort of take us through sort of a beginner's level, the immune system, from the types of immune systems we have to what they do and to how they influence these chronic diseases.
So what I'd like to propose, and this is my mantra that I'm bringing into this next discussion, that the information that we're going to share in the next minutes, if understood by the viewer listener of this podcast and executed at some level in their life, incorporated at some level, will make a dramatic impact upon their health.
What you're saying is we need to move from an inflammatory lifestyle to an anti-inflammatory lifestyle, and we're going to unpack what that is.
Let's start first by the obvious. A seminal paper was published out of Stanford Medical School a number of years ago. One of the authors was a former podcast guest that you'd had, David Furman, asking the question, is our immune system genetically controlled or is it non-genetically controlled? In other words, whatever our immune system is that just what we got? And the answer is that a very small amount of our immune system function is hardwired into our genes. The majority of our immune system function is not heritable. It is changed by the environment upon which we live that starts the moment of conception, that influences our genes of our immune system and how it functions. So that's number one, which gives us room to play, right? That means we can do something about it. That's good. Number two, recently, technology has been developed in which you can take blood from a person, even just a finger stick of blood, and using the technology available today, you can measure aspects of the blood, which is called the epigenetic component of the blood, to see what, using certain kinds of mathematical algorithms, your biological age is. And this has kind of become the rage recently, and you've talked about it in your podcast before, these molecular aging clocks that are developed from a blood spot. And then a person, hopefully, when they get their data back, it says, oh, geez, I'm 45 years of age, but my biological age is only 35. That's really good. Or not so good is I'm 40 and my biological age is 60. That's not so good. Now, what are you really measuring? And this is, I think, an important thing that a lot of people don't understand. When you take a blood sample, even a blood spot, that blood that you are giving for that sample is made of three principal things. One is water and plasma proteins. That's the liquid. Second is the red stuff in the blood, which are the red blood cells, the erythrocytes, which are the predominant cells. And then about 10% are what are called the white blood cells, sometimes called the buffy coat, and those are immune cells. So the majority of the blood that you have is not immune cells. The majority is either the plasma proteins and the erythrocytes. Now, it turns out that plasma proteins and erythrocytes don't have DNA. So when you're measuring then the biological age of a blood spot sample, you're actually measuring the age indirectly of the immune system.
Yeah. So essentially in English, that means when you take a sample of blood, the thing that we're measuring to look at your biological age is the DNA in your white blood cells, which is your immune system.
And I think a lot of people don't understand that. They don't know that. So when they get their data back, based upon what the algorithm was used to determine biological age, they're really doing it off that cell type, your immune cell type, to see what your biological age is. And there are different ways that data can be analyzed to give different methods of clock determination. Now, when I read these early papers, I thought to myself, well, hold it, if that's the case, then don't we have now a method of interrogating the age of the immune system against the way that a person looks, acts, and feels? What happens if we start studying the age of their immune system against their headaches, or against their energy level, or against their sleep, or against their arthritis, or against their cognitive performance, or in whatever variable, or their exercise tolerance? Now people are starting to do that. And then at the start of COVID, I was wearing my fitness monitor, my Oura Ring, and I got wondering, I wonder if the Oura Ring, when it's measuring these biometrics, is indirectly measuring aspects of my immune system. And so then I started to say, well, if you look at heart rate variability, you look at body temperature upon sleeping, if you look at sleep patterns, if you look at heart rate, if you look at respiration oxygen levels, all these things are indirect surrogate markers for immune system function. So then I started to say, could we correlate the immune age that we come off of our blood spot analysis with our Fitbit or whatever? In this case, I was using Oura Ring. And I did a couple of early papers on this, little publications. And then I found out that the company, Oura, was rapidly involved with studying with Stanford the relationship between the biometrics that come off the Oura Ring with that of immune system function. And they published the paper showing that you could detect some days before you got an infection based on your Oura Ring data, whether you were going to have an immune problem.
Wow.
These are the interesting things that we're starting to learn about how the immune system is connected to how we look, act, and feel. Then I started to say, well, what about obesity? Let's talk about that for a second. So I think that there's two types of obesity. One type I call friendly fat. This is like Santa Claus. That person doesn't have altered metabolic function. Their insulin's fine, their blood sugar is fine, their lipids are fine, their hsCRP is low. They have no apparent chronic disease, yet their BMIs are over 40.
Really?
Yes. And these people have been studied extensively. They have friendly fat. Now, what's the other kind of fat? It's angry fat. Angry fat is when those same fat cells in those people no longer at home, they don't feel at home. And they produce then their own set of responses to feeling not at home, which are called adipocytokines, which are inflammatory markers that travel in the blood to all of their tissues and say, I'm fed up. I'm as fat cells, I'm fed up and I'm not going to take it anymore.
Call it fire in the belly. It's like the fire in your fat cells in your belly that send a spreading fire across your body.
Precisely. And that's the immune system. Why? Because these same innate immune cells that we were talking about, macrophages, circulate also in the fat cells into the adipocyte mass, and they communicate with them. And if they're upset, they're going to tell the adipocytes, you ought to be upset too. And that makes angry fat. Now, what happens when they stick around for a long time and they do mischief? They die there. And what are those called? They're called crown cells. And you can see those In people that are metabolically unstable, that are obese, if you do a thin section under the microscope of their fat, you do a needle puncture biopsy and you look at their fat cells, you'll find these crown cells. Those are the skeletons of the dead immune cells that told the fat cells they should be upset. Now you're going to say to me, well, what's the percentage of people with friendly fat versus the people with angry fat? Well, it's a great preponderance of angry fat. And then that then begs the question, why would fat become angry? Well, it would become angry because the immune system is angry. Well, why would the immune system be angry? Where did it get its message? It got its message from the gut.
Yeah.
So if the gut's angry, then the liver is angry. That's NASH, which the fat cells are angry. That's metabolically unstable obesity. And then the microglia, which is the brain's immune system, is angry. And so what do we see? Dementia, fatty liver, problems as it relates to diabetes, and arthritis.
Yeah.
All interconnected to this web of understanding. So what's the treatment? Get rid of angry. Get rid of angry. What is angry? That's the immune activated cells that are trying to protect you against a foreigner called the way you're living.
So are you saying that the reason for the systemic inflammation throughout our body, this silent killer, this quiet inflammation that is not like the inflammation we learned about in medical school where there's redness and swelling and pain, that it's kind of quiet and you don't notice it, but it's creating this sort of smoldering fire. And are you saying that most of this is coming from problems with our gut microbiome?
That's a great contributor. We can also have chronic infections. We can also have xenobiotic exposure where the body says these are hostile molecules.
Environmental toxins.
That's right. So it's a total load effect that we've been talking about in our field for.
So low-grade infections like viruses, ticks, who knows what. It could be mold in the environment. It could
Precisely.
It could be our diet that's changing our microbiome and creating inflammation, sugar.
And that's why you're such an amazing detective, because you're the guy, as the clinician, that has pieced that together into an understandable, personalized approach to that patient's places. They don't have a defective immune system. Let's be really clear about this. They have an immune system that's doing what it should do based upon the exposure that it's been experiencing. And so the question
dealing
is,
with a bad set of circumstances.
That's right. And it fights back. When it fights back, it produces inflammation.
I think that's what I've always said for years, is that disease is just the body's best ability to deal with a bad set of circumstances, change the circumstances, and the disease goes away.
That's right. And so, this whole remarkable observation you've had reproducible with the 20-day detoxification program. I mean, what is that doing? That's lowering the exposure to all these things that the body might call upsetting.
Yeah.
And giving the chance the body to rest and the immune system to rest.
So this is sort of takes us to the next little portal I want to dive into, which is, so high level inflammation is basically the root of all evil in terms of chronic disease. We now can measure its effects through blood biomarkers, through epigenetic testing, which measures the control system on our genes and how it's turned on or off based on different influences. And we can then intervene with lifestyle or different foods or phytochemicals to see how the biomarkers change and how our immune age changes over time.
Yes, and we can see it change rapidly. We're not talking about years.
Yeah, so we've never really, it's one thing to say, okay, I'm going to give you a drug and see, or some food and see if it prevents a heart attack 20 years from now. But what's happening underneath is this chronic low level of inflammation, all these cytokines and inflammatory cells kind of going awry, leading to these chronic diseases. But we're seeing those changes happen far before you might have a symptom.
So let me give you an observation I made. This is my aha for the last 2 years. So I found this paper, which was called the Immune Inflammatory Index. I'd never heard of this before. And so I looked into it. It was actually some work that had been done in Denmark. I looked at what is the Immune Inflammatory Index? And it's actually a very simple algorithm that anyone can do from a blood test. It is taking the differential from a CBC, complete blood count, and putting it through a simple arithmetic equation that anybody can do because it's simple math, of the relative number of neutrophils, lymphocytes, and platelets in your blood from a standard blood test. You do a calculation, and it will tell you from the Immune Inflammatory Index, is what's called the result of that equation. If it's above 2, then you start to be into an inflammatory state that is associated with a whole variety of different diseases. And there are many, many papers now that have been published over the last couple of years on the use of the immune inflammatory index. So I started to talk to my colleagues about this, said, why aren't we using the immune inflammatory index? Because it's a standard part of every blood test that a person has. We're just not doing the calculation. Yeah. When we started using that and we looked at them before and after, say whether they were on tartary buckwheat or on these low allergy, low potential diets, your detox approach, lo and behold, the immune inflammatory index starts coming down very rapidly. It's a very simple test. And so now we have a simple marker. I'm not saying it's a be all and end all, but I'm saying it's a very inexpensive first level. So now we have this clinical observation trial that we're doing with a whole variety of people, including pediatric patients, with a group of docs that are willing to participate with us in looking at clinically how the inflammatory and immune inflammatory index can be used in their practice for designing personalized intervention. So this is where we're going. This is like a first level beachhead. It's very simple.
No. Most people just don't necessarily have access to full epigenetic testing and deep analysis. And, your company, Big Both Health, which has pioneered a lot of the work around immuno rejuvenation, understanding immunosenescence, immunometabolism, which we're going to talk about, has done deep analysis using special chips that look at epigenetics. This is not something you just get from your regular lab. It's a pretty sophisticated test. But you were sharing with me earlier that there's some surrogate blood biomarkers that you can use that we test regularly to infer what's happening at the epigenetic level. So what are those? So
there's a panel of the following. The majority of clinicians can have access to that are standard reimbursable analytes. The first, as I mentioned, is a complete blood count with differential.
Which measures your immune?
Your red cells and then your white cells, what type of white cells.
Yeah.
And you put it into this little equation.
Yeah.
The second is secretory IgA, which is measured in your saliva. So that infers aspects of your mucosal immunity, that first line of defense on the mucosal membranes that protect you against stuff getting into your body and creating mischief.
And you can measure that through a stool test or a cheek swab, but also through your blood. Is it as good to measure through your blood?
It can be done there as well. That's correct. Then the third is you've talked about it a lot. In fact, you mentioned Paul Ridker, who was a developer and promoter of high sensitivity CRP, C-reactive protein. C-reactive protein is a molecule made by your body's immune system, or actually by the hepatocytes, that is related to inflammatory burden. And this high sensitivity variant gives you a much more sensitive determination of your immune cell inflammatory potential. And anything above, say, 1 to 2 on that test is indicative that there's some kind of a chronic inflammatory condition that may be present. So if you use that small panel, all of which are inexpensive and readily available, now you have
CBC, IgA, and a CRP, HSCRP.
Right. That's where you start.
And what does that tell you?
Well, that will tell you if the person is in a state of immune unrest.
And do those go through some algorithm together?
They can conceivably. The way I think they're generally used by most practitioners is to look at them just kind of visually and see if there's an imbalance, because we know that the IgA is going to be an innate mucosal immune variable. We know that HSCRP is a systemic immune inflammatory variable. And we know your CPC data is going to be related to your hematopoietic immune system. So that would be a combination of innate and adaptive immune system.
And it correlates pretty well with the epigenetic changes in your genome.
That's what we're finding.
Inflammation,
Yes.
So is this sort of a clinical tool that you can do? And at Function Health, we offer this. You can go to functionhealth.com and test all these things and find out what your numbers look like.
And I can say, myself being a client of Function Health and now tracking, I've had 2 sets of analyses done. When I got more heavily on our program, the things that we're talking about, and that is really making sure I'm disciplined about these low inflammatory promoting things, including Himalayan Tartary Buckwheat, but the whole diet approach and lifestyle approach, lo and behold, all these markers that we're just talking about in my function improved.
What we have to do is figure out, in order to address this chronic disease epidemic, how do we reset our immune systems? Is there a way to rejuvenate our immune systems? Is there a way to understand the linkages of that to aging and to metabolism and to, all the things that we, are struggling with? We're struggling with our metabolism with the epidemic of obesity. We're struggling with degeneration as we age. And And the doorway into it just may be our immune system.
Well, let's look at Yamanaka factors. You spoke about that in your book. So Yamanaka factors won a Nobel Prize for their discovery, Professor Yamanaka, are these genes that are associated with longevity. And so people that have been into the longevity space have been trying to find drugs or ways of intervening to favorably influence the expression of Yamanaka factors to extend life.
Yeah.
One of those Yamanaka factors is a epigenetic regulatory agent for the patterns that associate themselves with immune system function. And so we're indirectly with those as one of the things that's associated with longevity affecting immune cell epigenetics, which affects immune cell function. Now, it turns out that we are learning, when I say we, that's a plural we, we're just a small little part of the bigger we, are starting to understand that the things that we do in our lives, including eating, send signals to these gene translation events that epigenetically mark and regulate how our immune system is going to respond to our environment. So if we eat diets that are gene regulatory and they put our genes at rest in our immune system, then lo and behold, we can tolerate a lot more stuff. But if we eat foods like high in sugar that do the opposite, that aggravate the way that our genes are marked for our immune system, now we're hypersensitive. Now we suddenly, and people will, you know this, you've spoken to it many times, the patients will start this spreading effect. They'll start with one thing and it gets worse and worse, and then it becomes pan everything. They become sensitive to everything because their immune system is so aggravated it can't discriminate anymore. Yeah. It just has pan allergic response to the world. Right. So this is all part of the regulatory process that occurs way upstream with the signals that the immune system is getting from how it's being treated.
So our diet has huge influence. Our exercise has a huge influence. Sleep has a big influence. Stress has a big influence. Relationships, community have a big influence.
Yes.
The presence of nutritional deficiencies and lack of optimal levels of nutrients plays a role. Lack of phytochemicals play a role. So there's all these things that are modifiable that we can do something about. And now we can actually measure their impact in ways that we never could before. You know, what's really striking to me with things like COVID is that its consequences are quite striking. Both the disease itself and maybe even the vaccine in acting in ways that suppress our immune system. Lyme disease and tick-borne infections are another example of microbes that seems to suppress our immune system. One of the ways we diagnose it is by measuring the activity of natural killer cells, which are depressed. And natural killer cells are exactly what they sound like. They're the hunt and destroy cells. They go after cancer. They go after infections and viruses. And they're part of your innate immune system that are so important in fighting everything. And what seems to have happened is that we've had a suppression.
Hold a second. Are we sure it's depression, or is it not that we have enhanced the turnover of those cells by causing their lower life expectancy? In other words, we've made them so senescent that they go away quickly because they are basically being killed.
Yeah.
And so it's not that we've depressed them, it's that we've turned them over more rapidly because we're not sustaining their functional ability.
Because all the things we're doing are causing them to kind of decrease in number.
That's right.
And that's what Lyme disease, that's what COVID does. Mm-hmm. I've seen this in certain patients. It's pretty striking to see this when you see across the spectrum of a population, particularly with long COVID, which is tens of millions of people in America. They're just things are off, like their immune system's off, and it's a form of chronic fatigue syndrome.
Yes,
like we had with maybe Epstein-Barr and other triggers for chronic fatigue, and it means that these people are less immune resilient, and they're likely to have all sorts of symptoms, and who knows what kind of diseases they're going to get. You know, there are now therapies that are being looked at that provide natural killer cells. There's a lot of research going on around, for example, how to take natural killer cells from your body, grow them in a laboratory, inject them back into you as a way of fighting infections or fighting cancer. There's this sort of concept of a bioshield that Patrick Soon-Shiong has talked about as an incredible physician researcher who's discovered a lot of these ways that we can treat cancer differently or treat infections differently. And so we're kind of in an era where our immune system, in one hand, is actually now working well. Some of the key surveillance mechanisms to deal with infections or deal with certain things we need to address. And on the other hand, we're seeing an overactive immune system. So we're seeing both these under and overactive immune systems that seem to accelerate inflammation even more. Well, did I get that right?
I mean, yes, you did phenomenologically. I think you did, but I think mechanistically, I think there's maybe a little bit more to the story. It has to do with the turnover and life cycle of these different cells within our immune system. So as we've said earlier in this discussion, immune cells kind of sacrifice themselves often for their defense. They will undergo cell suicide as a consequence of when they are overly called on. And so maybe what we're talking about as an immune system that looks like it's underactive with these natural killer cells is actually just that the system is so turned on that they're not able to replicate and keep their function. And so what we need to do is lower the burden to allow them to catch up.
Yeah.
That's right. So rather than give more natural killer cells, what we need to do is find the mechanism that's causing the eradication or the overactivity of those cells, their shortened lifetime, and reduce the senescence of the cells. As I said earlier, one of the most important lessons for me in all my years of studying cell biology and health is that every process that I can think of in the body that I've come in contact with has a destructive or a breakdown phase and a buildup phase. So think of this as a highway with two lanes. One lane is the area of breaking down. The other, on the other side of the highway, is a lane that's building back up. Now, in terms of metabolism, we call that catabolism and anabolism. We say catabolism is you break down macronutrients, protein, carbohydrate, and fat into calories of energy, and then you use those calories of energy to build back up tissues like muscle and other tissues that are needed. So catabolism and anabolism, we'd like to be balanced. But that can occur, that same model can go right down to every cell type. So let's talk about the molecules that we want to put a label on. Let's talk about prostaglandin E2, which we call an inflammatory molecule. So we say, oh, gee, we see a high level of that molecule in the blood if a person has a lot of inflammation. So we want to get rid of it. How do we get rid of it? We block it with an anti-inflammatory drug like indomethacin or ibuprofen. That blocks PGE2. Now, but when we block PGE2, what happens? Then we become more immune suppressed, and now we become more at risk to opportunistic infection. Mm-hmm. So it's not that PGE2 is a bad molecule. It's part of a balance of one side of the road. What we need is then a counterbalance on the other side of the road for PGE1.
Right.
And we can do that by properly navigating the immune system into resilience. So it's balanced between PGA2 and PGE1. That's just one of a myriad of examples that we could go through in physiology. So our role is to find ways of restoring that resilience so your body has that ability to go on both sides of the road simultaneously.
So what's really exciting is that we're now understanding how to intervene in this.
Yes.
Because, you hear people, I want to boost my immune system, or my immune system's not working, or I'm like chronically ill, infections, I have a suppressed immune system. There's something to all that, right? And I think, we understand how the system works now. We understand what influences it, what harms it. And it's the litany of things in modern civilization that are killing us all, right?
Yes.
The diet, the stress, the toxins, all the things we talked about, the increase in certain infections. And now we can intervene. So the question is, how do we start to think about this idea of immunorejuvenation to kind of reset our immune system?
We are right now, for the first time, I think, in human history, able to find some answers to that question. That's the exciting situation that we find ourselves in. So what have we learned? So let me go back, if I can, to universal learnings, historic learnings. You have done a lot in bringing out Dan Buettner's work with blue zones and how do they relate? And you've traveled these countries and you've spoken eloquently and you've been in videos and movies and you've brought to people's understanding that certain kind of simple lifestyles were associated with increased longevity. And so we started asking the question, what are the principles that kind of the through line that connect these things together, that when we actually ask questions about how these things influence their immune system, we can come up with answers, and those answers lead us into ways that we can employ that in our lives. Just this week, as we're having this conversation, in a very well-respected journal, Nature Medicine, is published this incredible study from Tanzania. Several thousand Tanzanians were divided into two groups. One group were individuals that were eating the traditional African diet. The other group were people that had become westernized, eating the westernized diet. So many cultures are undergoing that transition where you can find the fast food. And the study did a very detailed evaluation of what was the traditional African diet in Tanzania. Because obviously people eat their indigenous foods, the things that they grow and eat. So it's very plant-based. They have a lot of plantains and they have a lot of bananas, and they also ferment these. So it's fermented products. It's they have these non-glutinous grains, sorghum. And so it's very high fiber, obviously minimum processed, and very rich in phytochemicals and very colored. If you look at the photographs in the publication, which are colored, you can see these diets are very beautifully colored. Then what are the Westernized diets? Well, in the same country, they have photos of those. You could have those photos anywhere in the world. They're the convenience foods, the fast foods, the things that a lot of people are drawn to. And so they then studied the individual's metabolism and their immune cells with both these diets. Living in the same country, sharing the same gene pools. And what did they found? Exactly what we've been talking about. Incredible different marks on their immune cells when they ate their traditional diets with low inflammatory potential, low gene activation, low alarm response. Their fat was friendly, what little fat they had. And the other group, the Westernized diet group, exactly what we see in the rest of the world when you get into the Westernized diet. The immune cell profiles change. They become inflammatory potential, senescent, these secretory inflammatory types. They have the zombie cells. They have the issues of meta-inflammation. And so we can see this at the genetic expression level by the signals that these foods that they're eating are signaling to the genes that regulate then the function of their immune system. Now, I want to say...
So the key to unlocking healthy aging is to understand how to properly interact with our immune system.
Yes. In fact, what has been found, this is the last 10 years, is if you were to only measure one thing that would determine the year of your death, it'd be the age of your immune system. That's the best data we have today to date to predict your longevity, is the age of your immune system.
And that's really predicted based on epigenetic testing of the expression of your genes and which genes are turned on or off in your immune system. And that's what we're doing
now. And correlating that with epidemiological studies of longevity, which those papers are now being published. What we're talking about here may sound very matter of fact, but actually this is seismic changes in thinking, because now we have not just a paradigm, we actually have a model that is modifiable, and we have a rationale as to why these diets that were associated with blue zones have this through line of similar foods. Not the people in Tanzania don't eat the same foods in Sardinia, but they have this very high polyphenol content. They are very colored with their different phytochemicals, things that we have never taken seriously in American nutrition.
Yeah.
We thought that we could throw them away. We could process them to white because white is close to godliness. We don't need all these colored things. They just produce flavors. And now we don't have sweet and fat as a flavor. We have the flavor of whatever that polyphenol mixture is producing. We don't like that. We want sweet fat and salt. So this is a whole shifting recognition. When you asked me the first question on our discussion, why do we have so much chronic illness? It's all these variables that are changing at a time where we need maximum immune resilience, and we've taken away all the things that are needed for immune resilience. Duh.
So basically the colorful compounds in foods, what we call phytochemicals, are part of a strategy to rejuvenate your immune system.
Absolutely. So let me say one more thing to that. If you go to Google or wherever you want to search,
ChatGPT,
and ask, what is the historic value of these bioflavonoids or polyphenols in your diet? What it will say, I think.
And those are plant medicines. They're things that actually the plants use for their own defense, but that we've co-evolved with that actually regulate our biology in very specific ways and targeted pathways that we now understand.
Okay, that's what you say. That's not what ChatGPT will say.
Whoa.
It will say that they're antioxidants. That'll be the first thing it says. Now, I can tell you, I'm an expert in antioxidants. I think I fulfill that criteria. I started in the 70s and doing research and publishing papers. And I have always questioned whether that was the adequate explanation for how these flavonoids work. Now, it is true that they're antioxidants. It is true they'll soak up oxygen radicals. To me, it never seemed like an adequate explanation because Albert St. Georgi, who won a Nobel Prize, as you know, in chemistry for his discovery of vitamin C, he developed the concept of the guinea pig as the test animal. Do you know the story about that?
No, I know. He had a famous quote, which discovery consists of seeing what everybody else has seen and thinking what nobody else has thought.
That's right. And so what happened when he looked for a marker organism that he could test anti-scorbutic, anti-scurvy effects, he chose a guinea pig because it has this genetic aberration that we have, a gene that doesn't allow us to make vitamin C, which, like other animals, including the goat, can make vitamin C in their liver. Mm-hmm. In fact, the goat makes over almost a gram a day of vitamin C in its own liver. So he chose the guinea pig. And so he was able to show by taking paprika and extracting it, because it's very high in vitamin C, and he was the first guy to form crystalline vitamin C and gave it to the guinea pig and treated scurvy for the first time in the guinea pig model of scurvy. However, and this is a point that most people don't know, that if he used the ultra pure vitamin C, he only got the guinea pigs almost well, but they weren't totally well. The only way they could get totally well was to give them the impure vitamin C that had kind of an orange color to it. Like it had impurities from paprika. It wasn't purely crystalline white. And then they got well. What do you think that stuff was coloring the vitamin C? It was flavonoids. He called it vitamin P for permeability because it prevented capillary permeability. Then people said, well, it's not really a vitamin, so let's call it substance P. Then that got degraded to where it kind of completely got lost. He was the first person to start talking about actual specific effects of a flavonoid on a health outcome.
Incredible.
Now, let me give you another example. So you know dill. I think any person can detect the difference between dill and spearmint.
Yeah.
What is the detection you use to detect the difference between dill?
Your taste buds.
Okay, your taste buds. And what are your taste buds? They're neuroactive receptors of information from your diet, right? Mm-hmm. The signals that are coming from your diet. What are those signals? Those signals are something in that plant.
Right.
Those are molecules in the plant. Okay, now I'm going to give you a little factoid you may be unaware of. So what is the molecule that produces the flavoring of dill and the flavoring of spearmint? It's the same molecule.
It just tastes different?
It's called carvone. Now, here is the point of my story. It turns out the only difference between the carvone that's in dill and the carvone that's in spearmint is the way that it rotates plane polarized light. One rotates plane polarized light to the right. The other rotates plane polarized light to the left.
Wow.
That's called R and S carvone. That's a chemical nomenclature. They only differ by their handedness.
That changes
one is right hand.
The flavor.
Yes. To the extent that you would never mistake spearmint. Think of that for a moment as it relates to the information that our body's receiving. It is so precise that it's down to the ability to rotate plane polarized light in its specificity. So we just say flavonoids are antioxidants. That's BS.
Yeah.
They're cell-specific regulators of gene expression patterns. Mm-hmm. This is a pharmacopoeia of thousands of compounds that we eat in our diet.
So given that, and given that we have immune systems that are dysfunctional, given that we are understanding the role of immune system in metabolic health and aging and how to rejuvenate our immune system, I want to sort of dive into a specific plant. Which you've come to love.
Do I ever?
And you've spent, better part of a decade, I think, diving into the science around this and doing some extraordinary research. This is a plant that's called Himalayan Tartary Buckwheat. You've developed a company called Big Bold Health, which I'm an investor in, advisor to, and very proud to be. It basically has taken this ancient plant, which turns out to have probably more phytochemicals than almost any other plant on the planet that we've discovered to date, has sort of been a neglected plant. And you've taken this plant and subjected it to rigorous clinical trials, studies that have found some pretty extraordinary things with this. And this is a seed, basically, right? A flower seed.
It's a fruit seed.
Fruit seed, yeah. You can't really buy it that easily in the supermarket, but you've basically resurrected it from being kind of almost eliminated from the food supply, created a model of regenerative farming to grow it, which actually compounds the phytochemical richness of the food and increases it because the soil is how the plants get their nutrition. And if the soil's dead and dirt and not soil, if it's just devoid of organic matter, it can't take out the nutrients. So you've even sprouted it, which even accentuates a lot of these benefits. Yes, it's rich in flavonoids like quercetin, which has been studied for longevity, and it activates AMPK, which is a key enzyme in longevity pathways, and many other things. You found how it affects gut immune system function with its prebiotic fibers. You found how it actually enhances the function of natural killer cells, which are key to fighting infection and cancer, how it modulates inflammatory cytokines that drive inflammation in the body, all the chronic sterile inflammation we've been talking about, that it's rich in nutrients like zinc and magnesium that is important for function of your T cells and your natural killer cells, and it even has antimicrobial properties that are antiviral. So this is a plant that has a
plus it's high in protein, and its protein utilizability is close to that of meat. So
that's incredible. So it's really high in protein. It's low in starch and sugar, low glycemic load. It's quite an incredible plant that you've kind of resurrected from the mothballs of history. And one of the things you've done with this is you've subjected it to a trial in humans where you've measured through very complicated, sophisticated epigenetic testing, in other words, how this particular plant modifies the expression of our genes and is an immuno rejuvenator. Yeah. So can you take us down what that study was that you did and how this sort of works at a mechanistic level and what you discovered in terms of its effects on our genome?
I think that this work that we've been doing is kind of a model in which nature is giving us a peek into some of its mystery in ways that we didn't understand before. Nature doesn't divulge her secrets easily. I think you have to do it a step at a time. And so what we first found was this 3,500-year-old food. When we analyze it very precisely for its composition, we found there were 121 different phytochemicals from the polyphenol family across all the various families, the flavonol, flavonoid, flavone, and anthocyanin families. They were members across that whole range of plant compounds. So then I asked a question. I said, now hold it just a minute. Why would a plant go to the trouble, because metabolically it's very costly for it to make 120 different individual chemicals. Why would it do that? Maybe it only needs one thing. Like, why doesn't it just make quercetin? Quercetin has all these value proposition. Why doesn't it just make rutin? Why doesn't it just make homoaerodictyol? Why doesn't it just make, and I could go down the list.
Yes, you could, all 221.
And the answer is that nature is super intelligent because it has recognized that regulatory function of genes requires multiple cell-specific activities to orchestrate outcome for maximum resilience, to maintain the redundancy of our system so that we have maximum opportunities for positive outcome from exposure. Now, why do those flavonoids get built in the plant? It wasn't for us, obviously. It was because that's the plant's immune system.
Yeah.
And that plant is subjected to really hostile conditions.
Yeah, Himalayas.
Yeah, the climate is horrible, the soil is horrible, the insects are there, the mold and rust and all this stuff. So it has, plus it gets sunburned like mad. So it has to have
17,000 feet.
That's right.
You get more sunburn, right?
So it has all these members of its orchestra that are there to play the suite of immune innate function that allows it to survive for millions, well, hundreds of thousands, probably millions of years. And it turns out, lo and behold, that the mechanism by which that plant is able to protect itself by these compounds speaks right into the mechanism that our innate immune system in humans, when consuming that plant, can use as fuel, can use as information. So here's a specific example of food as information. It's not just an antioxidant effect. It's a gene expression effect through this epigenetic regulation of multiple genes that are controlling multiple functions. So now let's go to your question, which is, what about this research trial that we did?
Yeah.
So in this case, we asked in humans, without controlling their diet, just go ahead and eat your normal ad lib diet. So it's not going to be a diet-controlled study. What happens if we gave you a fairly enriched level of these Himalayan Tartary Buckwheat polyphenols, this array of substances, to the level that you were going to get about 1,200 milligrams a day? That would be equivalent to consuming about a half a cup of Tartary buckwheat flour a day. would be equivalent to that. And the reason we chose that is that there were data that had already been published in the Asian medical literature showing that they could show clinical effects in humans in terms of improved insulin sensitivity, reduced inflammation, reduced lipids when they fed that amount of flour to individuals. So I said, okay, let's study it at the gene level in immune cells. And lo and behold, in these individuals, when they consumed that level of these polyphenols over the course of 90 days, so 3 months, what did we find? Now, we were told when we started this study, we probably wouldn't find anything of statistical significance because the background of diet would overcome whatever signal we're getting from the supplement. But it turns out that was wrong, that the signal was so strong on our immune system of these 50 subjects that we had in the trial that some of the epigenetic patterns in their immune genes were amplified or altered by 20-fold.
Wow.
Not 20%, 20-fold. I mean, it just stood out like the Empire State Building, off of the other gene array.
That's like 2,000%.
Right, exactly.
And when we see an effect in medicine, we say, oh, it's a 30% or decrease in your risk of heart attack if you take a statin. And that's 30%. We're talking about a 2,000% impact.
Right. So then people would say, okay, interesting, but does it mean anything? So then we did a functional analysis as to what were these genes regulating in terms of the cell function. And they were regulating two interesting pathways or networks. One is called the ceramide kinase network, and the other is called COP9. This is a little scientific geekism, but what I'll tell you is that both of those are fundamental longevity pathways.
Yeah.
And so what this then translated to when we did the algorithms of aging clock analysis of the immune cells is that we reduced the rate of aging of those immune cells by 47% over the course of 3 months.
So basically taking a supplement with Himalayan Tartary Buckwheat plant chemicals or phytochemicals in 90 days reversed your immune health by 47%.
Reduced the rate of aging of the immune cells by 47%.
That's amazing.
I mean, this had never been shown before. Now, let me be very honest. This was a pilot trial, was a small number of subjects, wasn't blinded, wasn't placebo-controlled. So there's legitimate criticism that this doesn't fulfill all the gold standard criteria. So,
but you're going to fix that.
We are. We are doing an 800-person trial under very controlled, blinded, placebo-controlled conditions, initiated actually this month to be completed by the end of the year of 2025. We will wait and see. But this is the first study I think ever been done on a single food and its effect on immune cell epigenomic influence on cellular aging and cellular function, inflammatory pathways. I believe we will contribute to the body of science some that will leverage this forward in ways that have never been seen before. I am really excited about this because I think it not only will validate our thought that this Himalayan Tartary buckwheat is really an important agricultural product, but it'll also provide a model for which other studies can be done on many other interesting plant-derived things that are associated with longevity. And it gives us a testable model that we can replicate
across other foods.
That's exactly right.
Yeah, this is amazing. And I think, what's so interesting about this particular food is that it has it's like a multi-tool, like a Swiss Army knife of effects in terms of the body. And it doesn't just affect the immune system and inflammation in all the ways I describe it. It also has incredible effects on metabolism by regulating glucose metabolism. The fibers in it help with cholesterol metabolism, improve your HDL and lower your LDL, and helps liver fat, and it modulates something called AMPK, which is a critical pathway that a lot of people are studying related to longevity. It's one of what I call one of the 4 longevity switches that everybody's studying metformin for, but there may be other ways to do that without having to take a drug. And it has effects on the microbiome in ways that help blood sugar control. So there's so much going on there, not just the fiber in it, but also the polyphenols, which now are needed for gut microbiome health. So this is such an incredible food, and you've sort of resurrected it from basically the grave, have done a tremendous amount of research on it, and we'll link to all the studies that we talk about. But this is kind of a moment in history when we're finally able to sort of make sense of food as medicine, not in this abstract, high-level framework, but actually in a very specific way with very sophisticated testing that isn't available clinically, but as a research tool to see the impact of these molecules that we can get from our food. You can make I make pancakes out of it, muffins, but you can get the sprout powder, which it sort of enhances its benefit. And I put that every day in my smoothie. You can sprinkle it on yogurt or, put it in food. It's kind of like a superfood of the superfood in a sense. You're working this whole area. I had never even heard of the word rejuvenation until you said it, right? And never heard of immunometabolism. But now there's published papers on it. There's a whole field of research that's looking at this. And we're kind of at this historical moment where we actually can, in a granular way, use food as medicine and to actually help many conditions, but to more importantly, to kind of help us deal with the degradation of our immune system as we get older. And to find a way to kind of up level the function of it so that we don't get this enhanced inflammation as we get older, and that through multiple pathways. And I imagine many of the phytochemicals in this product are not fully elucidated in terms of their impact on our biology. We're sort of looking at holistically at what it's doing. We don't know what each individual compound's doing, but to me, it's really fascinating. Maybe we don't even want to do that because that can sort of a reductionist way of looking at things. But to me, this is sort of a great advance in science, and it's something that people can easily do as part of their daily supplement routine or their smoothie routine. I've sort of incorporated it automatically into my daily life because I think the literature is so compelling on this, and it's why I'm an investor. It's why I support the company and through my advisory role and just in terms of promoting it, because I think this may sound like a commercial, but it's really not. It's like this is just taking advantage of a tremendous advance in science that help us understand this sort of unique role between us and plants and our microbiome in plants and our immune system in plants and our metabolism in plants and how all that plays a role in optimizing our health and enhancing function. Because this isn't treating a particular disease, it's just making everything work better so you don't get sick.
The more we deep dive into this, the more we learn. And that's just a neat thing about science interrogation, that there's always another question to be answered. So when we started focusing on sprouting the seed, and we're looking for optimal sprouting conditions, we were able to finally land on a specific mechanism for sprouting that I was quite amazed, because when we did a compositional analysis of the phytochemicals in the sprout, as you had alluded to earlier, we had a threefold increase of the overall immune active phytochemicals. So it's like a superfood. And I think we have levels now in that sprout powder that's basically like a medicine. I mean, it's quite amazing. Now, here's the most interesting thing to me. When I looked at the compositional analysis, much to my surprise, I found out that there were very high levels of a specific anthocyanidin called delphinidin. Now, delphinidin has never been reported in anything at high levels, in anything other than berries. And there are clinical trials on delphinidin as a cognitive improver, as a substance that improves blood sugar. And the level of delphinidin in our sprout powder is therapeutically high.
Wow.
So then I asked the question, where did it come from? So what happens when you sprout, if you think about it, is that the sprout, life starts generating. And what life needs may be different than what the seed, when it was dormant, was storing. It's like the egg when it starts hatching. And so the principles of life then require certain things to be produced. And it turns out that in the hull of the Tartary buckwheat seed, there is a different composition of polyphenols than in the endosperm inside the seed, because the hulls have to be able to protect the inside of the cell against all the environmental damage. So what's in the hulls, the husks, are these anthocyanidins that are really good as protectors from environmental stress, to protect in the interior, which are higher in the flavin 3-ols that are necessary for metabolism. So now what happens when you sprout is you liberate the anthocyanidins that were in the hulls now into the mixture, so we get the full benefit of berries plus HTB in the sprouts. This is the first time it's ever been reported.
Incredible. So as you can kind of get from our conversation, we're in a whole new era of understanding food as medicine.
Yes.
And no one has been an advocate for that more than you, Jeff. I think you might have even coined the term. I don't know. For sure, food is information. And the information in our foods can help us to rejuvenate our function across a spectrum of different bodily functions. And the most important is our immune system. And it's something that now you've kind of pioneered as this new field of inquiry and also of clinical application. How do we then apply this in therapy? And you're not treating a disease when you take sprout powder, but you're modifying your risk of disease.
That's right.
And you're regulating your immune system in ways that help you stay healthy and end up reducing the rate of aging, which you've demonstrated clinically. So I'm really excited about the further research you're doing. I think we're going to stay tuned for that. I think we're going to keep talking about this for a long time. And Jeff, I just want to thank you for your life's work. And I don't know how you do it at almost 80 years old with a startup company, doing it all over again. But it's just a testament to your passion and care and interest in kind of continuing to educate all of us about the latest advances in science and medicine and how we can use that to help relieve suffering. So thank you, Jeff, for being on the podcast and illuminating this whole field of immunorejuvenation and immunometabolism, which I think is really the future of understanding health and aging and longevity. And it's something we can easily apply to our lives by just incorporating some of these things into our daily routine. And we're going to put links into all the scientific papers we talked about. We're going to put links into how to find more about Big Bold Health and Himalayan Tartary Buckwheat products, including sprout powder, which I think is an essential daily staple, including supplements that are derived from it and things that help your microbiome and many other things that you guys offer, which are really cutting edge in science.
Well, Mark, you're a gift to all of us. You really are. And I want to be very authentic about that. I was privileged to have met you in the AFMCP some many years ago and watched how you have spread your skills and talents to the world. And you're creating a better world as a consequence of what you do. So thank you so much. It's a privilege to be part of that.
Thank you, Jeff. That means a lot. If you love that last video, you're going to love the next one. Check it out here.